Hi guys, today we're going to be going over the algebra you need to know for the SAT. So I've pulled some of the most frequently asked questions that are going to be on the SAT, and on the SAT there's a large math portion. And in this math portion, algebra is one of the key concepts you need to know and master. So I've grabbed these questions from the official SAT and College Board, and they're ranked as the most frequently asked and the most difficult. So these are definitely some of the key concepts you need to know. Let's get started. Okay, this first question is line K is defined by y equals negative 17 over 3x plus 5. Line J is perpendicular to line K in the xy plane. What is the slope of line, a cutoff, but it would be K. So what is the slope of line K? So let's analyze this first. What is it really asking me? The slope. And it also gives me the information of line J is perpendicular to line K. Now, if you remember, a perpendicular line means that their slopes would be the reciprocal of one another. And we already know the slope of line K. So this is already given to us pretty much. We know the slope is negative 17 over 3x. Negative 17 over 3, that's the slope of line K. And if line J is perpendicular, that means that it is the reciprocal, the opposite reciprocal of negative 17 over 3, which would just be 3 over 17. It's also important to note that it's not just the reciprocal, it's the opposite reciprocal. So you need to remember the negative sign here, and you need to switch it because in a perpendicular line, it's also the opposite reciprocal. So this one is pretty straightforward, but it's also one of the key concepts you need to know in terms of linear functions. And it's just pretty much you need to remember what perpendicular means. Okay, moving on to the next one. This one is negative x plus y equals negative 3.5 and x plus 3y equals 9.5. Solve the system. Again, this is another one of the super common asked questions on the math portion. This is a simple system of equations. So it's giving you two different equations with two of the same variables, but it's multivariable, and it's asking you to find each of these variables. So what first pops into my head is I need to isolate one of these variables, and this one actually is pretty straightforward. We can see that negative x and x. Now this is great because they have the same coefficient of 1. So that means when we add them together, these two will cancel out because negative x plus x equals 0. So let's add these equations together. So negative x plus x equals 0, y plus 3y equals 4y, and negative 3.5 plus 9.5 equals 6, which means y, and now we can just find y, dividing by 4 on each side. We get 6 over 4 or 3 over 2. But for this sake, since they kept it in decimals, I'm going to turn this into a decimal too. 1.5. Okay, so now we know y equals 1.5. How do we find x? Well, we can just substitute this back into this original equation to get x. So I'm going to use this first one here because it's a little simpler. So we get negative x plus 1.5, because we know that's the y now, equals negative 3.5. So this is just simple solve for x. We need to isolate x, so minus 1.5 on both sides, negative x equals negative 5, and then divide by negative 1 on both sides, x equals 5. So now we can see that we have our two variables, and this would be our final answer. But if you have extra time on the SAT, you can always check your answers, and you should always check your answers. So that's what we're going to do. To check our answers, we can just substitute this back into the equation and see if it equals what it's supposed to. So let's take the first one again. So negative x, so it would be negative 5 plus y, which is 1.5, equals negative 3.5. Perfect, because now these equal each other, and we know that we solved for the variables correctly. And so overall, these types of problems, the main thing is trying to cancel out one of these variables. And this one was pretty simple, but if I wanted to cancel out y first, I would need to multiply this equation by 3, so that it'd be 3y, and we make sure the coefficients are the same so they cancel out. But the main thing is just canceling it out and then solving for the first variable, substituting, and finding the next variable. Okay. The next problem is a word problem. So an economist modeled the demand Q for a certain product as a linear function of the selling price P. The demand was 20,000 units when the selling price was $40 per unit, and the demand was 15,000 units when the selling price was $60 per unit. Based on the model, what is the demand in units when the selling price is $55 per unit? Okay, this one seems pretty challenging at first, especially since it's a word problem and there's a lot of numbers going around. But you need to break it down. So let's look at what it's saying. So it modeled the demand Q. So demand equals Q. And it's a linear function. This is very key to this problem. And the selling price is P. So now that we know it's a linear function and these are our two variables, we can see that the way that the price of P will be our x, this will actually be our x variable. Because the price will be dictating the demand. And so that means if this is causing this to change, that means this must be the y variable. And we know that it'll be like this because it's a linear function. And linear functions are always kind of built on this x and y type format. So that means that they already gave us a bunch of numbers as we continue to read on. 20,000 units was the selling price when the selling price was $40 per unit. So that means when it was 40, when x was 40, the demand was 20,000, which is the y. And then we continue on, and the demand was 15,000 units when the selling price was $60 per unit. So that means that $60 must be the x variable. And then 15,000 units must be the y. Perfect. So now it's saying, based on the model, what is the demand in units when the selling price is $55 per unit? Okay, so that means we know the selling price is $55 per unit. And we need to find what y will be. So now we have our equations. Okay, let's, I'm going to delete this so I have a little extra, wait. Yeah, let me delete this quickly to have a little extra room to do this problem. So now that we have this, we need to find the equations that they gave us from these two numbers. So what first pops into my brain, even though it might not be the fastest, we can just do y equals ax plus b, but we need to find the slope of these two. So the slope would just be rise over run. We can do 20,000 minus 15,000 over 60 minus 40, because that's the slope formula, if you don't remember. And so doing this quickly, we can see that this is 20,000 minus 15,000. That's 5,000 over 20. So that would be 250. So that means our slope is 250. X plus b. So now we need to solve for b. And to do this, we can just substitute again. So we can do 20,000 equals 250 times 40, because that's the x, plus b. So now doing this math quickly, we can see that this would equal 250 times 40 would equal 10,000. And so 20,000 minus 10,000. So B equals 10,000. Okay, so now we know our equation. This would be 10,000. Okay, now we can just solve. So we know x is 55. Plus 10,000, and you solve for y. Now, this is pretty straightforward, and I don't want to do the math, but you can obviously, when you solve this, you'll get the y, and you'll get one of these answers here. Now, this one is definitely very wordy, and that's one of the ways they try to trick you, but it's important that when you saw me going through this problem, I was just breaking down each sentence and the stuff they were giving me. So one of the most important things here is you identify that it says linear. And that should give you a clue. Oh, it might have to do with slope, x and y, stuff like that. And then after you do that they give you most of the information, and it's just solving then. Okay. Next up is another word problem. A certain apprentice has enrolled in 85 hours of training courses. The equation 10x plus 15y equals 85 represents this situation, where x is the number of on-site training courses and y is the number of online training courses this apprentice has enrolled in. How many more hours does each online training course take them on each on-site training course? So this one is another very, very wordy one. So let's see. A certain apprentice has enrolled in 85 hours of training courses. The equation represents the situation, where x is the number of on-site training courses and y is the number of online. So x is on-site and y is online. So how many more hours does each online training course take than each on-site training course? Well, we can just see from these, we need to analyze. It's trying to trick you again because it's giving you all this information, but in reality, you don't really need all of it because it's just asking you how many more hours does each training course take than does each online one take than each on-site. So we know x is on-site, and it's asking how much longer online takes. And we can see that these coefficients actually represent how many hours each of these courses take. So I really don't even have to solve for much because online takes 15 hours and on-site takes 10 hours, which means that the online training course takes 5 extra hours. And this is an example of the SAT trying to trick you. You really cannot get trapped in all the words it's giving you, and you need to focus on what it is actually asking you, because sometimes it is more simple than you think, but they are just trying to trick you. Okay. We have one more. According to a model, the head width in millimeters of a worker bumblebee can be estimated by adding 0.6 to 4 times the body weight of the bee in grams. According to the model, what would the head width in millimeters of a worker bee that has a body weight of 0.5 grams? Another word problem, and this one is giving you the equations you need. So it says, according to a model, the head width in millimeters of worker bee can be estimated. So let's say head width is W. Can be estimated by adding 0.6 to 4 times. So plus 0.6 to what? 4 times the body weight of the bee. So let's see, it's 4 times, and we'll call the body weight B. Okay, so according to this model, what would the head width be of a body weight of 0.5 grams? So now we already have our equation, and we can just substitute. And let's do that. So 4 times 0.5 would just be 2 plus 0.6 equals W. So this one's quite easy, and W equals 2.6 millimeters. This one is mostly about taking this line here and being able to interpret it. and not getting confused, because some people might do like 4 plus 0.6 times b, because it is confusing, but you need to break it down and know what it's actually asking you here. Okay, thank you all for watching. If you have any more questions, make sure to comment them. Make sure to subscribe if you want to learn more about math, and comment on any specific math questions you guys have. I'll be continuing to do videos like these. Thank you.